So we have a problem here where it says an open cardboard box is to be made from a piece of 20-inch square cardboard by cutting equal squares from the corners and turning up the sides. Let X be the length of the side of the square to be cut out. So this one, a classic problem. We've got a sheet of paper. It's 20 by 20. It's supposed to be a square. Something happened to it. But here it is. And what we're going to do is cut equal squares from the corner. So I like scrapbooking. Does anybody scrapbook? Okay. One person. Very good. Alrighty. That's pretty good. So I pretend that I've cut equal corners out of this. And then we fold this up to make a box. Right? In word problems, especially in problems like this, it helps to be able to visualize the problem. I don't know if you can do all this in the testing center, but at least hopefully you can imagine what it looks like. And so here we have a little sad box, but there it is. Okay? All right. And we're interested in the volume of this box. And remember, we started out with a piece of paper that was 20 by 20. Okay, so that means the length over here is 20. And then, of course, the length right here would be 20, I think, inches. Okay, but to make a box, we had to take these corners out. Okay, and then we, as you saw, I flipped them up to make the sides of my box. And there we are. Okay, so first they want us to find the volume. These are X by X, by the way. Okay, so volume equals length times width times height. Okay, so this was 20 by 20, but then I took those chunks out of the side that are each X by X. So what's the length of the side of this box now? Very good. Okay, we had 20 all the way across here, but now we're taking out X on the left and the right. So for our actual box, this little flap right here is 20 minus 2X. Okay, same thing on the side here, 20 minus 2X. That's our length and our width. 20 minus 2X times 20 minus 2X. What's the height of my box? X. Very good. Does everybody see that? We took the chunk of H, or not H, but X out. And then when I fold it up, this thing has to have a height of X. So this is my expression for volume. Okay, X times 20 minus 2X squared. Okay. Then they want us to graph this function so that we can see the necessary portion. What is the domain and what is the range? Before we even get there, what do you think the domain of this thing should be? Because that's going to be useful when we try to graph it. What's the minimum value that X could be? Zero. And what's the largest that it could be? 20, or probably more like, if we got to get one from each corner, it has to be what? 10. 10, 10, 10, 10. So our domain, even before we graph it, is going to be 0 to 10. Okay? All right, so let's see what we can get on our calculator as far as a graph. Okay. Right, so our function was x times 20 minus 2x okay, and I'm going to go on to my window and look at 0. I'm sorry. My minimum x value is going to be 0, and my maximum x value is going to be 10. Okay, let's go ahead and hit graph. See what we get. Crossing my fingers. Okay, I'm going to adjust a little more because do I need any negative values for y? No. Okay, so let's also make that 0. And I'm going to do zoom. Does this button say zoom? Okay. And we're going to do zoom fit, which I think is number 9. Let's see if that'll get it for us. Okay. Was it 0? Okay, zoom 0. Oh, thank you. Okay, there we are. Okay, so we got a little picture there. So the question we're trying to answer is, what? Graph the function on your calculator so you can see the necessary portion. What is the domain and range? Okay, so we already figured out what the domain was. How are we going to figure out what our range is? What do we need to determine from this picture? I need to figure out what this highest value is. This relative what? Max. I need to figure out what that is. So one way that I can do that on the calculator is to go to trace. So my little cursor is now on my curve. And then I'm going to do second and hit the trace button again. We want to do some calculations. And number 4 is maximum. Okay, it's going to ask me to go to the left of where I think the maximum is. So there's my cursor, and I believe the maximum is right here. So I'll hit enter. And then we'll go to the right of where we think the maximum is. Enter. And then they ask us to take a guess. It doesn't have to be a great guess. And so at 3.333 blah, 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 we get y equals 592, we'll say 0.6, okay, approximately. All right, so I'm going to say then that my range is from 0 to 592.6. Okay. Find the value of x for which v has a maximum value. I think we already found that. We said it was what? X equals 3.33. Right? Y'all with me? Okay. Or did y'all go to lunch already? Okay. Did you put your function in the same way that I have it here? Okay, x times 20 minus 2x squared. Okay. Okay. All right, I'll look at that in just a second. Do we have another question here? Nope, that's it. Okay. So that's how we could solve that problem. And answer all of those questions. Okay, questions about that. All right, looks like we made it to the end of 2.5. We've got about 4 more sections to cover before we get to a test. So certainly by the end of next week, we need to be thinking about a test. If we don't take it next week, then it'll be the week after that, okay? I will see you all on Thursday.